I'm Lukas. I'm glad to be here at SWIP 24 today. I'm a research software engineer at ZDMed in the Information Center for Life Sciences in Cologne. And today we're showing the web application for our MeSH vocabulary translation software, where we translate the MeSH vocabulary into German. And I've been leading the development since 2022 for that. So first of all, I will give a short introduction what medical subject headings are, and then I will introduce the MeSH translation process. I will then head on to present the technical aspects of our term curator platform, and I give a short demo of the term curator to see what the user interface for the translators look like. And in the end, I will show the resulting MeSH file that we also publish on the website. Starting with MeSH. MeSH is a controlled vocabulary for life science that has been published by NLM since 1916. And since then, it's regularly being updated. New MeSH terms are being added year to year. And for that reason, we are tasked to submit translations annually. NLM uses MeSH for their own biomedical database PubMed, in which MeSH is used to index publications as well as to support with search requests in their own search engine. And MeSH itself consists of a hierarchical tree structure. Hence, you see on the right there the MeSH symbol, supposed to be a tree, which makes it a thesaurus. The use case of MeSH, as I said, mostly consists of indexing the publications in life sciences. On the right side here, you see a snippet of a publication on PubMed about measles on non-human primates. And here you can see the list of all the MeSH terms. With the asterisk means that this MeSH term is one of the major concepts of this publication, and the lowercase letters would mean that, so the uppercase letters are headings, and the lowercase letters would be subheadings in this case. I will talk more about them afterwards. Another purpose of them is to refine the searches of the publications, so the PubMed engine uses MeSH. I will show that also. And another topic would be named entity recognition, which both the PubMed engine uses and also could also be useful for NLP solutions. Here you can see a screenshot of a search query using MeSH directly on the PubMed search engine. I've inputted the MeSH heading COVID-19 and the subheading diagnosis. So this way it will show me the results of all the publications that contain both of the heading and the subheading that I've input in the search query. About named entity recognition. So named entity recognition is a useful tool if you want to merge two different words together. So here you can see the MeSH entry for overtreatment and overtreatment with a hyphen. Both of them are entry terms that are linking to the descriptor that uses the preferred term overtreatment. What it does is, in the PubMed search engine, if you input overtreatment with the hyphen, it reads it the same as if you put it without the hyphen. So this is quite a useful tool to avoid this problem that you have a different kind of spelling, or you have a very close related synonym that it recognizes that. It is also useful for NLP. So in NLP, it means that you do a machine learning, that you perform a machine learning model on the text itself. And on tools like Word2Vec, it could be quite useful to condense the vocabulary down a bit so that it doesn't need to train each word individually. It will recognize that overtreatment and overtreatment with a hyphen are basically the same word and treat them as such. So it doesn't train those two words separately. Moving on to the MeSH vocabulary types. MeSH has 4 general vocabulary types. One of them, the first one are headings, also called descriptors. That one we focus on our translation process. And they're basically concepts that are found in biomedical literature. They can be quite broad. So examples would be vaccine efficacy, COVID-19 testing, and dental health services. Then we go on to the subheadings that I've mentioned before. They're always the lowercase letters there. and they are used in combinations with headings to focus on aspects of an article. And there are only a handful of them. I believe there are less than 100 of subheadings, while there are tens of thousands of headings existing. And some examples of them would be classification, standards, and adverse effects. And then they also have publication characteristics, which are just the types of the index publications. So examples would be comment, study, and review. And the fourth one would be supplementary concept record, which are separate from the MeSH thesaurus themselves because they serve kind of a role to process newly added concepts that have not gone through the review process yet. So those could also be indexed in publications without needing to wait for the approval of the MeSH term. These ones we don't translate at all because unless they become MeSH terms approved as MeSH terms themselves, then we will treat them as well. And for example, for MeSH heading entries, so this is on the MeSH website where you can look up the MeSH terms themselves. I've opened up light pollution, and you can see here that this light pollution would be the MeSH heading, would be called the MeSH heading. Underneath there, we have the scope note, which is a description of the MeSH heading. It can be just one short sentence or a long description with a link to it to give further explanation. In this case, I picked a really short example. Then we have the subheadings that are related to the main heading. And moving down, we have our unique ID. This would be called the descriptor ID, hence the D. And each descriptor has usually has a large set of entry terms, which would include the descriptor itself, which are usually different ways of spelling the word. So you don't say light pollution, you can say pollution light instead, or closely related synonyms such as sky glow that can be used to replace the terms. And I will go more into detail into them now. So basically we have three layers. The first one would be the descriptor, as I said, light pollution. Then we have the concept layer, which are concepts that are related to the descriptor themselves, and each of them has their own preferred label as well. In this case, light pollution has three concepts in total. One of them would be the light pollution itself, then sky glow, and then artificial light at night. And on the bottom layer are the entry terms. Those are the terms that are actually being translated. And we see that that light pollution only links to light pollution, which is the preferred label for both the concept and the descriptor. For sky glow, we have sky glow and artificial night sky brightness. Sky glow would only be the preferred label for the concept sky glow, while artificial night sky brightness would be a synonym, and so on. Moving over to translation of MeSH entries. So MeSH entries, we are being requested by NLM annually to provide yearly translations of the newly added MeSH descriptors. The purpose is to increase the accessibility for researchers that are publishing their works in languages other than English, or that are searching for works in other languages. And it also enables NRE operations in other languages. So if you're training an LLP model on Spanish and you're using Spanish literature, then having the MeSH entries translated into Spanish would be quite useful for that. And the currently known bilingual versions are using French, German, Norwegian, Spanish, and Swedish. Our team is focusing on the German translation only. The translation process is all decentralized outside of NLM. So other institutes in their host country in which the language is spoken majorly perform the translation service and provide the translator's file to NLM by also publishing it themselves. Until 2018, the German translations were performed by the Federal Institute for Drugs and Medical Devices. After a 2-year break, we've taken over the process. So since 2020, ZWMed is working on the translations. And unlike our predecessor, we've developed our own custom web-based MeSH translator that we named Term Curator. And the publications are in the bilingual MeSH file that we publish in both XML and RDF format. Quick overview of our translation pipeline. First, we need to await the new MeSH descriptors provided to us by NLM. Then we load in the initial MeSH entries. and perform the initial translation using DeepL API, which is a large language model to translate languages. I think it also supports a large set of languages. It's more specialized on German, so this is why we prefer to use this. And then we go on to the multi-level curation process, where we also have a layer of quality insurance to assure that all of the translations are accurate. And in the end of it, we upload our bilingual MeSH entries in XML and RDF format and send it over to NLM and publish it on PUBLISSO. And for our translation web application, our idea was, the reason why we decided to develop our own web application for this. So we wanted to perform a user-guided development process in which we work with the users directly and see what their needs are and implement features based on their needs and requests. This was quite useful for us because previously the translation was performed on a software provided by NLM directly, which had the disadvantage that it couldn't be customized. And since we developed our own system, we could add our own features that streamlined the translation process to make it more efficient and easy to use for the translators. One of those features is that we use DeepL for initializing the translations. This is not those are not supposed to be a final translation, but they are supposed to bring a starting point for the translators to work on. And another feature that we added is the multi-level curation process, in which we have one level that the translators propose their initial translations, and another level in which those translations are being approved upon using a quality insurance team that assures that the translations are all accurate. And we also perform high scalability with an easy and simple management for term assignment and splitting of translation tasks, which aims to, so in case we have 1 year where we get twice as many new terms, we can easily decide for the next time that we want to double our amount of translators. And without much trouble, we can implement this in our website, where we can split the tasks among multiple groups of translators to more efficiently translate the terms. And another one big advantage is that we use we make resource readily available to the translators so that they have quick access to the scope notes and additional resources that I will show in a bit. For the technical aspects, we initially developed it on Python using the Flask framework. Later we decided to migrate it to the Vue 3 framework Nux 3, using the combination of JavaScript for front end and TypeScript for the back end. The idea was that we wanted to implement new features that required a proper database setup, and we wanted our website to be more scalable. Hence, we decided to move it to a more modern framework, Nux 3, which was newly released at the time. And for backend, we use Prisma ORM to implement an SQL-like database which stores all the MeSH translation data as well as any user information. And the server deployment is done on our own servers using Nginx. Here's a small demo on the interface that the translators see. First, they see their terms, their descriptor list of all the descriptors that they are supposed to translate. Here you can see on the left the descriptor ID, the English terms. Those would be always of the concept that are related to the descriptor itself. And you can also see the color coding, so that the translators can easily identify which of those rows are still to be translated. In this case, the black words would mean that they're to be done, while the orange ones would be marked as to review, and the blue ones are done already. And they already get the germ terms populated via DeepL. And if we open one of those rows, we see the translation model table. Here you can first see the scope notes, which are directly taken from MeSH. As I've shown before, every MeSH descriptor has one scope node that the translators can easily access, we don't actually translate those, but we like to include them into the UI so that the translators have quick access to the description. Below that, you can see the two concepts. Usually, a descriptor only has one concept, but this time it has two concepts in total. So below the concepts, we list all the entry terms that are related to this concept. And we also use our germ terms that are pre-editable and pre-generated with DeepL. On the left side, we have our term types. So it could be either a pref label or a synonym. A pref label in this case, if you remember the hierarchy that I've shown before, that a pref label would always mean that this is the preferred term of this concept. In this case, fermented beverage would not only be the preferred term of the concept, but also the preferred term of the entire descriptor. And the other term types would always be synonyms. And we can also add additional synonyms. This is quite often the case in the German language, that it's quite often the case that the German languages has more synonyms to an English term. Hence, we usually end up with more German translations than English terms in the XML. In this case, so I've added one new row, and the translator can then decide I want to write another synonym there, or they can remove additional synonyms, but they can never completely remove the pref label, which always has to occur in one of the concepts. And other helpful tools are on the right, where the translators can easily access additional resources. In this case, we have direct links to Google, Google Scholar, Wikipedia, ICD-10-GM, and SWND. And clicking on the links, they will directly open a search query that is related to the German term that is pre-generated by DeepL, and they can double check if this is the correct translation. After all the translations have been approved, we generate the German MeSH XML, which consists of both the English terms and the German translations. On the right here, you can see a tree snippet, an XML tree snippet of the last year's publication, in which I've opened up the descriptor light pollution, and you can see on the term list that we have 4 terms in total, and one of them would be the descriptor header, and below that would be the German translations, and they are treated equivalent to the English terms. So in this case, we also give the German terms their own ID number. Normally they have an ID number of T, but we needed to assign their own ID number since we have an uneven number of German terms, and they are not always associated to the English translations themselves. Currently, we also have more than 100,000 translated German MeSH entries. Those have been collected over decades already, so this number is usually not the case for every year, that we usually get a few thousand, and over 2 decades it might build up to more than 100,000. And all of that is published by ZBMed on PUBLISSO. And this would be where you could download the file on PUBLISSO. PUBLISSO is our own hosting website for publications. And here, for example, would be the bilingual version of the 2023 release, which is currently the most recent release. For future work, we are working on the new 2024 release. There's also a new task of a new request by an LM that we also need to handle the change terms, which haven't proven quite a challenge since all of them have their own change type. Some of them are deleted terms, and we also have to deal with the moved concepts and descriptor IDs, and newly added synonyms to existing descriptors, which is different to our usual work that we deal with new descriptors themselves. And we are building an entirely separate pipeline for this that has a different approval process to approve deletion requests and movement requests that are also automatically processed by our system if no manual intervention is necessary. And after that, we will process the previous MeSH term changes that have built up over the past few years. So this is the goal for next year. And thank you everyone for listening. I'm open to any questions. So stop sharing now.
Thank you. Yeah. So there's interest in your tool. Where's the source, Luke?
Currently it's all private. It's currently not open source yet, but I can't speak for others if we want to put it open source in the future. Since it's mostly an internal software used by all translators, we are still happy. I suppose we are still happy to provide additional information and help through other teams.
And what do you think would be adjustable to other vocabularies, or is MeSH very, very special?
I think MeSH is quite unique in its set. Our system is mostly specialized on the specifics of MeSH itself. So we have to deal with the hierarchical structure that it has, and we can't really use it for any other vocabulary right now.
Okay, so I think there's interest if it gets published as open source. Yeah.